Well, we've been studying linear equations and solving systems of linear equations. Well, this time we're going to be solving just linear inequalities. Our next lesson will be solving systems of linear inequalities. But right now we're focused on just one linear equality. So let's see what we can do here. For linear equations, the solution is every point that is on the line that represents the equation. For example, we've got a line here. Let's say that, well, let's write this down. Let's say this line is y equals negative x plus 2. Okay, and we've graphed this line. Well, the solution to that equation is every point that lies along this line. Okay, every point that lies along the line there. Now let's say that we have a system of linear equations, and we have y equals x plus 2. We've got a different slope this time, and so we can draw a line. Oh, let me get up here and draw the line. So we draw a line and it goes through there. And where's the solution to our system of linear equations? Right, it's where the two lines meet each other. Well, in linear inequalities, the solution is all the points that make the inequality true. So it can be everything that is on this side of the line, or it can be everything that's on this side of the line. So linear inequalities are just a little bit different than equations. Excuse me. For an equation, remember the line would be the answer. For inequalities, it can be the line and everything on that side of the line, or the line and everything on this side of the line. Or it could just be everything on this side of the line, or anything on this side of the line. Let's look at an example. We've got y is greater than x minus 3. You remember that when you're graphing, the first thing you do is you look for the y-intercept. So the y-intercept is negative 3. So let's come over here and we'll graph negative 3. 1, 2, 3. The next thing you look at is the slope, and the slope is 1 over 1. So we come over here and we go up 1 over 1, up 1 over 1. I do several points on here because it's easier on me. Up 1 over 1. And then we draw a line. Let's put our arrows on our line. And then there's one other thing. Whenever it says, well, let me get off here. Whenever it says y is greater than x minus 3, it does not say y is greater than or equal to. Okay? If it said y is greater than or equal to, it would include everything on that line. But because it only says greater than, that means we do not include the line. So we come over here and we make it a dashed line. That's how we indicate in algebra that the line does not include the answer. So we've got a dashed line now, and we need to know where to shade. So the next thing we're going to do is test it. So I come over here, and typically I will test 0, 0 because it's the easiest one. So I will go 0. 0 is greater than, and the x would be 0. 0 minus 3. 0 is greater than negative 3. Is that true? Well, yes, that's true. So since we tested a point on this side of the line, and that was true, that means this side of the line is the one that we shade to indicate our answer. So our solution is all the points that are on this side of the line, and it does not include the points that are on the line. Alright, the next one, y is greater than or equal to negative 3. We've already graphed this one time. The only difference is that this time we've got or equal to. So I'm going to give you the shortened version of graphing this because, like I said, you've already done it one time. So we come over here and we graph negative 3. Then we go up 1 over 1. We draw our line. And this time, let's put our arrows on the end of it. This time, the line is going to remain solid because it says or equal to. And remember, we tested the line over here, 0, 0. We tested that, and we know that we're supposed to graph above the line. So this would be the area that we shade, excuse me. Okay. Now, we've got y is greater than or equal to negative x plus 2. The slope on this one, you get a different color. The slope on this one is negative 1 over 1, and the y-intercept is positive 2. So you take this one and do it now. Pause the recording. Try this one. Come back and see if you got the right answer. Okay, let's see what you did. I got negative 1 over 1 and positive 2. So we'll come over here and we'll go to positive 2 as our y-intercept. Then we'll go down 1 and right 1, down 1 and right 1, down 1 and right 1, and we'll be able to draw our line now. Okay, now is it going to include the line? Well, yes it is, because see, it says right here or equal to. So that means the line will remain shaded. And let's put our arrows on each side of the line. And now the question is test it to find out where we're going to shade. So we come over here and let's test 0, 0. So we go 0 for y is greater than or equal to negative 0 for x plus 2. 0 is greater than or equal to 2. And now, is that true? No. 0 is not greater than 2. So we come over here and we tested here. We know that we got an untrue statement, so that means we do not shade this side. We shade the other side to indicate that's where our solution is. Okay? Did you get the right answer? Alright, our next one. Y is less than 2/3 x minus 2. We're going to graph it. Our slope is, our y-intercept is negative 2. So we come over here and put our point at negative 2. Our slope is 2 over 3. So we go up 2, right 1, 2, 3. Up 2 over 1, 2, 3. And we can draw our line. And we put our points on each side of the line, our arrows on each side of the line to indicate it goes on forever. What other thing do we know? Well, because this says y is less than, and it does not include or equal to, that means that the line is going to be right. It's going to be dashed because it does not include the solution. And then the final question is the final thing, not the final thing, the next to last thing that we need to do is test. So let's come over here and we'll test 0, 0. And so we're going to go 0 for y is less than 2/3 times x, which is 0, minus 2. 0 is less than 0 minus 2. 0 is less than negative 2. Is that true? No, it's not true. 0 is not less than negative 2. So that means that we do not shade this side, we shade the opposite side. Okay? Alright. Your turn. Y is less than 3/4 x minus 4. Y-intercept, slope. So you take your turn, pause the recording, and then come back to me. Okay, I've got negative 4 as the y-intercept. So we go 1, 2, 3, 4. We've got 3/4 as the slope, so that means we go up 3 and right 4. 1, 2, 3, 1, 2, 3, 4. And we draw our line. Now, is the line going to be shaded, or is it going to be, is the line going to be solid, or is it going to be dashed? Because it says it is less than, but does not say or equal to, that means it is going to be dashed, right? So we put our dashed line, we put our arrows on each side, and we've got our line. Now, let's test it to see where we're going to shade. We can test 0, 0. 0 is less than 3/4 x minus 4. Oh, excuse me, times 0 for x. And so we got 0 is less than 0 minus 4. 0 is less than -4. Not true. So that means we do not shade this side. We shade the opposite side. Did you get that one right also? Okay, y is less than or equal to 1/2 x plus 2. You can already see the difference in this one because we've got the or equal to. Well, since we've got the or equal to, that means that you know already that the line is going to be solid. So let's graph this one. We've got a y-intercept of 1. And we've got a slope of 1/2. That means we're going to go up 1 and over 2. Up 1 over 2. Up 1 over 2. And we draw our line. The line is going to be solid because it says or equal to. And the line is going to have its arrows on each end to indicate they're going forever. Oops, I missed. Got it. Okay. So now where do we shade? Let's test 0, 0. Let's do a different color. So we'll have 0 is less than or equal to 1/2 times 0 plus 1. 0 is less than or equal to 0 plus 1. 0 is less than or equal to 1. Well, that's true. So that means that we're going to shade on the side that we tested. So we'll shade on this side. I hope you're getting a good grasp of it by now. Alright, we've got x this time. This time it only involves x. So what kind of line? Since a y, when it involves only a y, it's a horizontal line. When it involves only an x, yes, it'll be a vertical line. So we've got x is greater than or equal to -1. So we'll come over here and we'll put our line x -1. Let's do a different color. X -1. And we're going to draw our line through there. Now, is it going to be a solid line or is it going to be a dashed line? Yeah, it says y is greater than or equal to, so that means it's going to be a solid line. So we've got our line here. The question now is, where do we graph? Okay, where do we shade? Excuse me, where do we shade? So we come and test 0, 0. So instead of x, we're going to put 0 is greater than or equal to -1. Is that true? Yes. So that means that we tested right here. We got a true statement. That means that we're going to shade on the side that we tested. Okay? All right. Other patterns. All of these say greater than or equal to, greater than. What pattern do you notice about the shading? Right, it's shaded above in each instance. Right here it's shaded above the line, above the line, above the line. Okay? How do you know which side is above the line sometimes though? The way that I do it is I pretend that I've got a ball. Let's see, let me get my ball. I pretend I've got a ball. And if I take the ball and I put it right here, what's going to happen to it? Well, in this case, it's going to roll down, okay? If it's going to roll down, that means I've got it on top. If I put the ball here, what would happen to it? It would fall. That would mean I've got it below. So that's the way that I tell, when it gets difficult, how I tell where the above and below is. Okay? What pattern do you notice here? Less than or equal to, less than. And where did we shade? We shaded below the line for less than. So the thing that you'll get used to, okay, still think it's good to test to make sure that you're getting it right. If you want to make sure you're getting it right, you'll test. But whenever it's less than, you shade below. Whenever it's greater than, you shade above the line.